Now this circular motion, it is divided into two types. The first type is called as uniform circular motion. And the second type is called as non-uniform circular motion. In short, it is written like this UCM, and this is written like this non-UCM. Now here we will explain only these two types and we will stop. Now we know the definition of the circular motion. The motion in which the particle is moving along the circumference of circle, it is called as the circular motion. In case of the uniform circular motion, the diagrammatic representation is shown like this. Suppose if we consider this is the circular motion of the particle, it is moving along this circular path. Suppose this is given as this like this. You see here? Suppose it is moving in the anti-clockwise direction. So in case of the UCM, I will write here omega near to that. What this omega indicates? Angular velocity. But it is not taken in the vector notation. It is taken as magnitude of angular velocity. So magnitude of angular velocity is called as the angular speed. Or we can say linear speed, because if this is the position of the particle, let it be this is the tangential velocity, this is the radius or the position vector. So you will get idea about this. So uniform circular motion means the circular motion in which the angular speed or linear speed of the particle remains constant. म्हणजे जेव्हा पार्टिकल गोलाकार मार्गाने फिरणार आहे तेव्हा त्याचं लिनियर स्पीड किंवा अँग्युलर स्पीड कॉन्स्टंट असायला पाहिजे. So this particle will cover a certain distance in certain interval of time. When the particle is moving with the uniform speed, so you will get the such type of motion. It is called as the uniform circular motion. Now what will be the non-uniform circular motion? The particle is moving along the circular path, but its speed is not constant. Means its speed is variable. Means the circular motion in which the linear speed or angular speed of the particle does not remain same. So it is called as the variable speed. So such motion is called as the non-uniform circular motion. So in this case also you will find the same thing. Suppose the particle is shown here, then this is the direction of the velocity, this is the direction of the radius, and suppose the particle is also moving in the anti-clockwise sense of direction. So these are the two types of the circular motion: uniform circular motion, which is called as UCM, and another is non-uniform circular motion, which is called as the non-UCM. म्हणजे तुमच्या लक्षात आलेलं असेल की युनिफॉर्म सर्क्युलर मोशन मध्ये पार्टिकल एक समान वेगाने फिरत असतो, तर नॉन युनिफॉर्म सर्क्युलर मोशन मध्ये तो व्हेरिएबल स्पीडने we can consider the example for this uniform circular motion and example for this non-uniform circular motion, so that you will get idea about it. Now when we consider about this circular motion, then we can consider the motion of moon. Motion of moon around earth. Motion of moon around the earth, it is an example of UCM. The moon, it is a moving with the constant speed around the earth. एक समान वेगाने चंद्र हा पृथ्वीभोवती फिरतोय, त्याचं स्पीड कॉन्स्टंट आहे, लिनियर किंवा अँग्युलर स्पीड. सो यू विल गेट दिस इज अ एक्झाम्पल ऑफ युनिफॉर्म सर्क्युलर मोशन. Similarly, all the planetary systems you can observe, त्या पूर्ण planetary systems मध्ये सुद्धा आपल्याला uniform circular motion दिसणार आहे. What we can say about now non-uniform circular motion? So this is a one very important example for non-uniform circular motion, that is a vertical circular motion. Vertical circular motion म्हणजे जर आपण मेरी गो राऊंड पाहिलेलं असेल, जत्रेमध्ये वगैरे असा जो पाळणा फिरत असतो, तो फिरत असताना ऍक्च्युली तो कंट्रोल केलेला असतो. बट जर आपण ग्रॅव्हिटेशनल फील्डचा फक्त जर विचार केला आणि अर्थचं ग्रॅव्हिटेशनल फील्ड फक्त त्याच्यावरती जर ऍक्ट होते असं जर आपण मानलं, तर इन केस ऑफ द व्हर्टिकल सर्क्युलर मोशन, याला आपण बॉटम पोझिशन म्हणतो किंवा लोएस्ट पोझिशन म्हणतो, इथून फिरून आपण टॉप पोझिशनला जातो. हा प्रवास करत असताना हियर वी हॅव कन्सिडर द व्हर्टिकल सर्कल. मग ज्यावेळेला पार्टिकल असा फिरतोय, इन केस ऑफ द व्हर्टिकल सर्कल, द वेलॉसिटी गोज ऑन चेंजिंग. म्हणजे वेलॉसिटीची डायरेक्शन तर बदलत आहेच, पण त्याच बरोबर त्याचं मॅग्निट्यूड सुद्धा बदलतं. सो यू विल फाइंड इन केस ऑफ व्हर्टिकल सर्क्युलर मोशन, इथं जर पार्टिकल असेल तर त्याची वेलॉसिटी वेगळी असते, टॉपला गेला तिथं त्याची वेलॉसिटी वेगळी असते, दोघांच्या मध्ये असेल इथं कुठेतरी इंटरमिडिएट पोझिशनला तर त्याची वेलॉसिटी वेगळी असेल. म्हणजे खालून वरती जात असताना टॉपला गेला वेलॉसिटी वेगळी आहे, वरून खाली येताना परत त्याची वेलॉसिटी बदलत जाते. सो दिस इज द कंपॅरिझन फॉर द युनिफॉर्म सर्क्युलर मोशन अँड non-uniform circular motion. Now we know the definition of the circular motion. With the help of that definition, we can define the uniform circular motion. Means this is a type of circular motion in which the particle is moving with constant linear speed or angular speed. So the particle is moving in anti-clockwise direction with a constant angular velocity. So this is a representation of the uniform circular motion. While in case of the non-uniform circular motion, you will find the particle is moving along the circumference of circle, but angular speed or linear speed is not constant. So this is a non-uniform circular motion. For to distinguish the diagrammatic representation, you can write omega over here, so that you will get idea about this. This omega, angular velocity, is considered constant. The angular speed, magnitude of the angular velocity. Okay. So if we compare the uniform circular motion and non-uniform circular motion, you will find this is the diagrammatic representation. Again you will find the definition for this. The circular motion in which the linear speed or angular speed of the particle remains constant, it is called as the uniform circular motion. So the circular motion in which the linear speed or the angular speed of the particle is variable. It is called as the non-uniform circular motion. So first point you can remember, that is a definition which is already we have explained here. So you will find this is the first point, that is the definition. Secondly, when we consider about the particle is moving in a circular motion, then we know, suppose this is the position of the particle, then you will find this is the direction of the linear velocity, this is the direction of the radius or the position vector. In case of this uniform circular motion or a circular motion, you will find there is radial or centripetal acceleration. Similarly, if we consider in this diagram, then you will find the position of the particle P, which is denoted here. This is the direction of the tangential velocity. The particle is moving like this is the position vector. Now here also the particle is moving in a circular fashion, so you can observe the radial acceleration is there. But you will find the difference is that in a uniform circular motion, the particle is moving with the constant linear speed or constant angular speed. So this radial acceleration, you can observe it is a constant. It is a constant. While here you can observe the particle or the speed of or the direction of the velocity goes on changing. We know when we consider about this radial acceleration, it is responsible for the circular motion. So here you will find it is also the radial acceleration. Here it is also the radial acceleration in both cases. But here radial acceleration is constant. Radial acceleration is constant because speed is constant. Here speed is the variable. So you will find here the value of radial acceleration is not constant. It is not constant. You will find again, as the speed of the particle is not constant, there is the formation of the tangential acceleration. So you will find here the tangential acceleration is produced in the body, and this tangential acceleration is in the direction of the tangential velocity or opposite in direction to this tangential velocity, because the speed is variable. When the speed goes on increasing, this tangential acceleration is in the direction of tangential velocity, and when the speed decreases, then this tangential acceleration is opposite to the tangential velocity. And we know in case of the uniform circular motion, this tangential acceleration is 0. Tangential acceleration is 0. So you will find here, because of the variable speed, the one more tangential acceleration you can observe in the direction of tangential velocity or opposite to it. In case of uniform acceleration, uniform circular motion, tangential acceleration is 0. And the fourth point, you can remember the example related to this. In case of uniform circular motion, we have seen the motion of moon. We have seen motion of moon around the earth. while in case of non-UCM we have seen that is vertical circular motion, that we have seen here. So you can remember this is the main difference between the UCM and non-UCM. So in this diagram, if you want to show, then you will find this is the direction of this tangential acceleration, or it may be in this direction which is a tangential acceleration. So these are the possible directions of the tangential acceleration in the non-uniform circular motion. If we consider the linear acceleration, then linear acceleration has the two components. Now in this explanation here, if we consider A is the linear acceleration, then you will find there are two components of this. So if we consider, suppose this is the diagrammatic representation for this, then you will find here, suppose this is the radius or the position vector, this is the direction of the velocity, then we know the direction of this radial acceleration, it is along the radius towards the center of circle. The position of the particle is considered here, the center is considered as O, and the particle is moving along the circumference of circle. Okay, so the tangential acceleration is suppose along this direction. So you will find here, this is the direction of the tangential acceleration, maybe upward or maybe downward. Okay, so if you observe this radial acceleration and this tangential acceleration, they are always perpendicular, because we know the radius tangent perpendicularity theorem. So the total, this is a linear acceleration, it is called as the radial component. It is called as the radial component of linear acceleration, and this is called as tangential component of linear acceleration. So we will get idea about this. And this linear acceleration, it is nothing but the addition of these two. So also we have seen in case of uniform circular motion, this tangential acceleration is 0. So in case of UCM, okay, tangential acceleration is 0. Therefore, the total acceleration, linear acceleration, it is only of the radial or centripetal acceleration. Radial or centripetal acceleration. Now here we know these are the vectors. So suppose I want to find out the value of magnitude of acceleration. So from this formula we can find out magnitude of acceleration, and this magnitude of acceleration is A is equal to under root of AR square plus AT square. So you will find here this formula, that is A is equal to under root of AR square plus AT square. It gives the magnitude of the linear acceleration, which is in terms of the radial acceleration and the tangential acceleration.